Alright, here's the back of review 1. It says today there is, well, let's jump ahead to the end. Let's read through what we're actually trying to figure out here. It says, are the two events independent? Alright, so that means, when we read that, that means we want to figure out if the probability of A given B equals the probability of A. I'm not going to use A and B because I want to use R and L. So let's look here. We have a little bit of information that's going to help us get the given probability, but we didn't start with that. So the conditional probability is, remember, equal to, let me start using R and L. Let's do rain given lightning. That's going to be equal to the probability of rain and lightning. This should be on your topic sheet because we went over this formula in class, over the probability of lightning. So that's equal to rain and lightning is 0.15. Change the percents back to decimals. And just lightning is 0.20. So the conditional probability is equal to 0.15 divided by 0.20, which is 0.75. Okay, so that's going to go with that one. All of that was just conditional probability. Now we need to compare that to the probability of just rain. So here we have probability of rain and lightning. Now we need just rain. Oops, P. The probability of just rain is 0.55. So, since these two do not equal each other, the conditional probability of R given L does not equal the probability of R. No, they are not independent. So as soon as you read this question, are the events independent? You're going to need to compare the conditional probability to the overall probability. And then to find the conditional probability, we needed to use the conditional probability formula. Now suppose that today there is a 60% chance of rain. Oh, again, let's switch to the bottom. We want to know the probability of rain and lightning. And we are provided with just rain, just lightning, and the conditional probability. Well, conditional probability, the probability of rain or lightning given rain. Well, we just used that formula. Lightning given rain will be equal to the probability of lightning and rain over the probability of just rain. So what I'm looking for here is this. That's what we're going to try to solve. I know the other two pieces. There are 3 pieces of information here. I know 2 of them. I know lightning given rain, which was 0.20, sorry. We don't know the probability of lightning and rain, so that's going to stay as variables. But we do know the probability of just rain. So I have probability of just rain, the probability that's given, that's extra information. And then I'm going to multiply both sides by 0.60. And we get 0.60 times 0.20 equals 0.12. So I looked at the information that I was provided, and I looked at the question. The question said probability of rain and lightning. And I was given the conditional probability. So I used that. Notice that you get a different answer if you just use probability of rain and the probability of lightning. If you use the multiplication rule, which you could, if you use the multiplication rule here, you get 0.09, which is not too far away from the answer I got, 0.12. What that actually shows is this is another way of showing that two events are not independent. That you're not being asked for that information. So I would accept either one of those answers because both of those are valid ways of showing the probability of rain and lightning. But calculating them those different ways shows us that the events are not independent. It's another way to show that. Alright, next one. What's the question we're being asked? Chance of lightning and rain. Sorry, something weird happened when I copied and pasted. Alright, what is the chance that we'll have rain or lightning today? So that's what we're looking for. Or means union, which shouldn't trigger you to remember that we're going to use the addition rule. So we see the word or, we think about that being the union, then we think, okay, that's the addition rule. So the addition rule says the probability that we have rain or lightning is equal to the probability of rain plus the probability of lightning minus the probability of rain and lightning. So that's 0.55 plus 0.20 and then minus the 0.15 and that all equals 0.60, so 60%. And one more from the back. What's the question? We're being asked about just lightning. So we are given that we have 50% chance of rain. That should be an up, I'm sure. A 60% chance of rain or lightning, and a 15% chance of rain and lightning. Well, alright, so that's tricky. We want just a single probability. We have the single probability of rain, we have the union probability, and we have the intersection. If I think about where all of those things occur, this happens again in the addition rule. Now, I know that that's something that maybe doesn't come naturally to you, but you want to think. Which formula has the probability of rain, the probability of rain or lightning, and the probability of rain and lightning? Which one has all three of those as well as the probability of lightning? Well, all of those appear in the addition rule. So that's going to be the probability of rain plus the probability of lightning, which is what we're looking for, minus the probability of rain and lightning. So probability of rain or lightning, that's 60. The probability of rain, 0.50. We don't know the probability of lightning, but we do know the probability of rain and lightning. And so now I have a little bit of an algebra problem. These two are like terms over here. I don't know why I have that. So we have 0.60 equals 0.35 plus the probability of lightning. 0.50 minus 0.15. That's where the 0.35 came from. And since I'm trying to get the probability of lightning by itself, I'm going to subtract these from both sides. And we're left with the probability of lightning is going to be equal to 0.25 or 25%. Hopefully the light bulb problem at the end wasn't as bad as these ones.